talk about RAG and sort of where the direction it's going and agentic search, how I see the picture evolving, sort of where we've been and the clean break that we're making from the past, I think, with agentic search. So that's going to be a new thing that we're going to talk about today. For those of you who don't know me, my name is Doug Turnbull. I'm basically software Doug everywhere. There's my website. I do retrieval consulting. I do a lot of training, and I've advised and worked at probably hundreds of companies from Wikipedia to Reddit to Shopify as a consultant or as an employee. I built some of the early RAG systems that, or helped build the search behind a lot of the early RAG systems at Reddit and Shopify. I recently worked at a fashion AI startup, Daydream. So I've done this a couple of times now. And, written a bunch of books. There's a bunch of logos. If you want to get to know me, definitely head to softwaredoug.com. I always like to talk about what's coming. I like to keep my Maven channel full of interesting talks. We're going to have next week, many people may know Joe Christian Burgum. I think I may have misspelled his name now that I see that. And he's the CEO of Hornet. He's well known for being a sort of common person that you see, and he's well known for being sort of like from Vespa, the search engine, and has maybe gotten a reputation as the BM25 guy from that perspective, and now he's becoming more and more agentically focused. He works now at a agentic search startup called Hornet, and Hornet is interesting because yeah, it's entirely built a search engine entirely built for agents as the main user, not humans. So I think it's really interesting. So we're going to have a great conversation next week. Um, and then in a couple weeks, there's a great in-person conference down about a mile from my house, actually, in Virginia, called Haystack. If you want to find just a great conference on retrieval and search, you can't do much better than this. I know a lot of people here will already be there. I'll be there. A lot of other great people will be there. Many people may know Trey Granger. He'll be there as well. So definitely come hang out with us. That's May 5th through 7th. Um, I am going to be teaching a course, and the link got kind of hidden here, for called Cheetah Search Essentials. This is a free course I do before I teach my paid course, which is all about agentic search. This free course is just a really great time to come and learn if you want to come get like the basics, explain like I'm five perspective on search. Definitely encourage people to come check it out. Um, Yeah, and then finally, I have my live training coming up in May 18th, about a month away. It's all about the stuff we're going to talk about today. Basically from RAG to agentic search. And that comes in lots of flavors. There's lots of components to that, from building harnesses that search up to the actual retrieval part of the equation. I think this agentic search space is basically going to be in 2026. It already is the main thing people talk about when they talk about information retrieval. It's what embeddings were to the late 2010s or so. Um, it's a pretty consistent finding. This is why if you're an AI person, I like to always have these quotes, why you should care about search. I mean, the most consistent finding, and you'll see these quotes all over the place. One of the most consistent findings in the research is just that retrieval and search really drive the quality of AI systems. So that's, and you can see it. This is like a data point you can get over and over again. And we're actually seeing more data points because it's still true with agentic search. No retrieval, retrieval added, retrieval optimized. Like you can get like 2x improvement just by improving the retrieval quality. This is classic RAG. There's some nuance to this with agentic search that we're going to talk about because agents can participate in their own search in a way that classic RAG was not, was not able to. So today we're going to talk about information retrieval. We're going to talk about the progression uh, from sort of this question answering era that we all know and love into the RAG era. And then I would argue the cleanest break comes when we're adding agentic search to the top, to the world. When agents come around, it's actually a fairly clean break from this and the RAG era. And we're going to talk about that a bit later. So back in my day, when we talked about AI, we really were talking about things like this. The Google answer box to us was magic. This was like the late 2010s, what we meant AI, what we thought AI was. And I find it interesting that, the definition of AI continues to change and change as we go on. So this is the sort of like we would just the fact that we could sort of do this thing where we could figure out the similarity between a query and a passage. This is an interesting case because it doesn't necessarily go with how we typically think of search. We have a query and a relevant passage. And nowhere in this passage this is about a book called Ubik by Philip K. Dick, who's kind of a really crazy sci-fi author who's always doing interesting stuff. Nowhere in here, what is the book Ubik about? Really, the term book or Ubik doesn't really occur in this passage at all. But through the question answering era, we learned that we could train a query encoder and a passage encoder to take labeled passages and queries so that they produce embeddings that produce the right, that say that they're similar or not. So this is actually the synopsis of the book Ubik, but no keyword search solution without a lot of work could easily come up with this as the top result. So that was sort of what we were all amazed by in the late 2010s, and this was like state-of-the-art cool stuff. So now anything that looks like the training data of this model can be encoded, can have queries encoded or passage encoded, and probably do a pretty good job of noticing when the passage is the right answer for the query or when it's not the right answer for the query. As long as it kind of looks like the training data, and that's something else we'll talk about. We also had things like extractive question answering, where we could, within a larger body of text, take the begin and end of a question. So this question is like, what are minimalist running shoes? We can do things like figure out the probability that a token in a larger document is the starting point of the answer and when it might be the end point of the answer. So we can do things like pull out just the little sentence that directly answers our question, which helps us implement things like answer boxes when we need to pull out a snippet of what the right answer is. So we were like in the late 2010s, we were really excited about this kind of stuff. And it really took off. So we built a model for every data type that you can imagine. You can go on Hugging Face and get an embedding model trained on just about any kind of data that looks kind of like your data, and it will probably do a pretty good job of getting the right sort of relevant answers for the questions that you're asking. Here we've got a legal one, a medical one, there's e-commerce ones, there's embeddings for everything these days. Now, the real thing that would happen is that people would take an embedding, I'm going to use an embedding, and most people could easily stand up an application that could use the embedding, but very few actually did the last 20% of fine-tuning it on their data for a lot of reasons. For one, it's actually really hard. Another major reason is because training data is often founded in being good at evaluating search in particular. So there's like evaluation data takes a lot of time and effort to actually label something as relevant or not. So this is sort of becomes a big stopping point for anyone actually going and getting embedding to the next level. Just the data science required to gather clean and good training data. And so a lot of people would be fine with an 80% solution. Um, yeah, very few actually evaluate, even fewer fine tune. So you had all these startups that were doing question answering and maybe beginning to do RAG that were 80% search solutions that worked great for some things and then catastrophically failed at other things. But even that 80%, was really impressive and people were really excited to use embeddings. And back in the early 2020s, late 2010s, if you wanted to take one of these new embedding models and deploy it somewhere in a large scale set of infrastructure, you didn't have a lot of options. I remember back then there were libraries like Annoy. People might remember that. There were the beginnings of vector databases. People would deploy some of the vector index libraries into a Docker container and kind of get by with that, or they'd re-rank the results from these are your traditional search engines like Elasticsearch, Solr, Lucene. They might re-rank what comes the lexical candidates based on embedding similarity. Um, but to do actual embedding retrieval wasn't really an option with the traditional search indices. So you kind of had this parallel path where everyone was getting excited about taking these embeddings down and standing something up really quickly, where we had the rocket ship of vector databases, where some people may be frustrated with the traditional search world, got really excited and said, you know what, this is a data structures problem. It's really cool and fun and interesting. And there are entire systems now that are just started out as we would call them vector databases. Increasingly, they're just adding other types of indices like full text search that really help take the Hugging Face batteries and shove them into something that's going to really power them at high scale. And so you just had a huge amount of search startups that were literally just, I can download a model from Hugging Face, I can index your data, and I can help you discover stuff. And that sets us up for what happens next. The next thing that happens out of the question answering era is this really cleanly evolves. It's almost like the kindling and the fuel. It's like we're out there with a dry with a forest that's dry. It's really windy, and all of a sudden there's a spark, and all the ingredients came together of having mature vector databases, having Hugging Face with embeddings, and ChatGPT dropped. And the first thing that we notice with ChatGPT is it immediately hallucinates, right? LLMs hallucinate. If I actually did this recently, I think I might have asked it not to search, asked ChatGPT not to search, and asked it to give me blog articles that I wrote, BM25 posts by Doug Turnbull, and I got these things that seem like something I would write, but I never wrote any of this. I don't have blog posts of this of these titles. Some are like, but they're things that are reasonably associated with me. Of course, what people realize is pretty quickly, if I just took that prompt, that question I'm asking, and I appended to it, it's like, here, give me BM25 blog posts, and oh, by the way, here's a list to help you. It would nicely use this context, these search results that we've appended. The LLM probably doesn't even know that they're search results, they're just extra context, and it could more accurately answer the question. So now these are blog posts that I have actually written. So this is like the old school RAG that we used to do 2023 into 2024. And of course, this to most people looks exactly like what we were talking about. The first assumption is I'm going to take a prompt. We're going to have an LLM that helps me write queries. It's going to ask questions of this index. The index is going to come back with answers and help the LLM respond. So the vast majority of the people getting into the space, and many folks on here may may be among them, we're getting into the space, finding embeddings from Hugging Face, shoving them into the vector database of choice, and just going to town and getting a pretty good 80% solution, RAG solution, right? And we also we figured out that to preserve for several reasons. One, because they embed better into more meaningful answers if we just chunk up our larger content into smaller pieces. And they save LLM context so that it makes sense to chunk them into answers or passages. And we'd embed both of them. And it sort of felt like if you saw this to a lot of people, it just search was solved, right? This was all you had to do. If you had a good enough embedding, if you had chunks broken down, and you had good questions coming in, there really shouldn't be any reason you can't answer every question that an LLM has. That's the theory, at least. Well, the first chip in this that breaks down is, of course, embeddings never 100% fit. Even if you fine tune them on your data, you're still going to encounter queries that are novel and new. Users are going to change how they're searching. But for the most people, they're not fine tuning. They're taking something that works 80% of the time, and there's this last 20% that actually that doesn't necessarily work well with our against the embedding model. Maybe we took some medical records embedding model, but because of our location or our specialty in medicine, our queries look just and our data look just slightly different than what the model was trained on. And 9 times out of 10, teams that do this, they don't necessarily have an ability to just take down and fine tune some data. They don't have they don't have good enough training data to do that. They don't have the data science capability to do that. It's a pretty big cliff to figure out how to fine tune it. So you're left with this awkward overlap of something that works 80% of the time, but not the other 20% of the time. So for those cases and for other cases, we have BM25 as well, which is, I like to think of it as a fairly defensible, understandable ranking. Here we're just sort of counting and weighing things by their term importance. What are good baby names? Name is sort of moderately important. What is not that important to this? Baby may be more important and so on. And people who may know BM25, and definitely if you don't, come to my class on it. But it's literally just defensible lexical scoring to kind of give you reasonable results. And the great thing about it is it's not really trained on anything. It just sort of works for just about anything with term matches. So it's a lowest common denominator really fast, and it just works. For a broad case of use cases, whereas that embedding model is going to be very tailored, so maybe even overfit to a specific set of training data. So we add it to the stack, and we're pretty sure it's solved again. But then we realize that that's not enough too, because just getting the top vector embeddings or the top BM25 results is not enough. Those can be fairly inefficient retrievers. Sometimes there's actually some structure to our data, and to get good candidates for our LLM, we need to work with that structure, not against it. So we realized that we can add content understanding, maybe tag with a stock ticker. Also, query understanding, there's a stock ticker XYZ here for earnings report from XYZ. And we filter our indices maybe down to get to those candidates that are pretty, more accurately closer to what we want. And we also realize things like there are more recent reports that we care about more recent things than older things, and these other bits of like metadata kinds of filtering that sometimes are expressed in the query. And in the end, we've just recreated basically the traditional, uh, yeah, I think I'm sharing the slides. Sorry. We're basically recreating the traditional query understanding stack. We're basically recreating what searches always look like. So there's really strong continuity between this question answering era and the classic RAG era. Even though a lot of consultants like me, a lot of startups have made a lot of, made a lot of noise about RAG and everything. A lot of that noise, honestly, was just teaching people how search normally works and the pieces that go into it, where we have multiple retrievers, we have query understanding going in, trying to filter things, and we have re-ranking maybe coming out, and so on. It starts to just look very similar. But what I want to emphasize is getting into the agentic era is actually a much more dramatic break from this older school way of thinking about search for 1 or 2 decades that we've been doing. So, and I'll talk about that. That's what we're going to talk about for the rest of today. The first chink in the armor came around with structured outputs. So it used to be that we would beg an LLM to produce valid JSON. We might say, hey, can you take this query and please, pretty please, get the color or the stock ticker or some bit of metadata out of this query or this bit of content, and please, pretty please, format it in such a way that corresponds to how we think about things, and please, pretty please, only return legal colors or stock tickers or whatever other bit of metadata that exists. But now with structured outputs, we basically constrain the schema that the outputs of an LLM can be. We force it to obey a pydantic schema, which is or a JSON schema. It's basically a typed interaction now. It's not just a natural language bit of text that comes out. So when we say, give me BM25 post by Doug Turnbull, well, maybe our stuff, we've tagged them with topics and authors. Um, this doesn't look like a natural language question. It looks like almost looks more like what you would do a sequel. You could imagine a select star where topic equals BM25 and author equals Doug Turnbull. So this becomes a specification. And then you start to realize, wait, all those years before, we've been obsessing about natural language question answering, when now with structured outputs, we're getting away from the unstructured perspective and getting more and more to a structured perspective. And just to give you a sense of what this looks like, I don't know why that says color. That should say stock tickers. And I like to live edit slides. So let's do that right now. Yeah. So it should be stock tickers. And we can say this is how the output that an LLM should produce. We can say something like, you're an helpful assistant that helps create search queries. Generate a query for earnings report XYZ stock. And it's going to return something of this schema before. It's going to return a stock query schema. And let's edit that too. So that basically turns the LLM, and the LLM, this is the LLM in RAG, this is the LLM that's just forming a query that we're going to then go and append to our main context. This basically turns it entirely into a structured interaction and has nothing to do with natural language search that might use vector embeddings and all kinds of stuff. So that's the first thing that happens. The next thing that happens is, so before, if I do this, I can still follow the same flow where I give the LLM a prompt and a bunch of context that should help it answer the question, even if this was interpreted as a structured question. On the side on the left, there's usually an LLM that's helping to turn the user's prompt into a query, but it does it. The LLM that's answering the question right here doesn't know it's participating in a search. Well, now the next evolution becomes tool calling. So with tool calling, LLMs know that they're searching. Um, so give me BM25 posts of Doug Turnbull, and an agent, when it's using tools, will speak in a same typed schema full language to do things like go to topic BM25 author Doug Turnbull. So this is starting to make my point of like all that stuff that we've done with classic RAG, where we've chunked data, we've built embeddings, all of that was tailored towards an embedding retrieval and natural language question answering paradigm. This is starting to look like a completely different paradigm. And it's not clear to me if you're starting out as doing some kind of quote unquote RAG system that you should do the chunking or embedding retrieval. You may be better off using a completely different system. Yeah, and classic, this is basically the same point. Classic RAG focus natural language search tool calling. You can do natural language search. There's nothing stopping you, but you can just as easily use the structure imbued in the data itself. And if you think about this further, we used to spend, like people say, well, my data is not very structured, it's not very clean, blah, blah, blah. And we used to spend, there are entire startups that would spend years building PhD level ways of taking a specific content type like patents or earning reports or blog posts or jobs and just enriching them with structure. Well, now, if you know what you're doing, you can have an LLM sit on your content, add the structure that's needed to answer the questions that your agent needs to have answered. And then your agent can more or less generate queries now that are in a more structured kind of vocabulary that look more like something like this, what of the information that's needed. And when you have a query that's a bit more like a specification of metadata, that looks more like metadata similarity. Like this is now I'm going to sorry keep switching domains, but here we have a query for crimson suede couch. Well, crimson is a type of red, suede is a material, couch is this material is this type of couch. And if we look over our corpus, you can see some things in this metadata language that are much clearly much more similar to these attributes than other things. So you might say red is obviously a direct match. Pink, we might consider a match, but maybe ranked lower. You can decide whether you want to include imitation leather or not. You start to think about these things as a similarity over metadata, not anything to do with traditional embeddings or lexical retrieval, BM25. And I'm not saying this because you should never use BM25 or embeddings, but I'm just saying what I'm really getting at is that LLM, it has never been cheaper to turn your unstructured data into structured data and turn your queries and prompts into structured tool calls. It's never been easier or cheaper to do that. And doing that will only make the other kinds of ranking you use, whether it's embeddings, if you are using chunks or BM25 or something like that, will only make that more effective. And to me, when I go to work with teams, this is one of the biggest blind spots and opportunities that people have when it comes to search and RAG, is they've spent a lot of time focused on data modeling on the chunking and embedding, and almost no time on trying to enrich the data and the queries with the metadata needed to actually get down to what's really important and make those other ranking systems work. Those other maybe fuzzier, in some ways, probabilistic ranking systems work more effectively. Hmm. Okay, so that's these two things, maybe the query understanding, that I think that's more and more obvious to people that we LLMs do a good job of that with prompts now. We don't need to build that in our search stack necessarily. The second point of tools, I feel like it's becoming clear to people, but maybe people aren't necessarily aware of just how powerful that is in terms of uh, being able to interact with our data in a more structured fashion. And then finally, we have reasoning itself. So reasoning, once a agent executes a tool, in this case, searching on its own behalf, and it gets a response, it can analyze that response and act and think like, the user searched for BM25, but the keyword search didn't find what we needed. Let's be more specific. So we changed the topic to BM25 and author Doug Turnbull and so on. And so a lot of how we build search is how these days in agentic search and why this is such a clean break with the past is trying to encourage agents to think and reason and use its tools more effectively as much as it is about the retrieval quality and all those other good things. Um, and you can see this in the data. So if you have, this is on, there's a notebook link here I definitely will share out. But if you just take a set of tools You have a BM25 tool, you have embeddings tool. That might be a poor embeddings model for this. And over some, this is just a standard e-commerce data set. You can see just BM25, just adding reasoning makes search better. It goes from 0.52 to 0.58 and DCG. Same thing with embeddings, gets a little better. And then if you give it both, it gets even better. So you get a pretty significant like 10% bump just by like, hey, agent, here's some dumb tools. Try to find the most relevant results for these queries. This is using just GPT-5 and like whatever medium level of reasoning. So I'm not saying this to necessarily for you to go and inject GPT-5 on into your search stack, but just be aware that the other thing that's happening, and I'll talk about this later, is that people are working on cheaper reasoning models that can plug into a search stack and maybe could work on more traditional search queries. Companies like Sid, I know Chroma has had a model come out recently, and those are going to probably really change how we think about this stuff even more, add sort of fuel to this fire. So if we're giving we're just throwing tools and we're giving lots of options to the LLM to filter on metadata and the agent to filter on metadata, does retrieval not even matter anymore? Well, I, luckily someone today actually shared this paper with me, and I think it's really enlightening because it does show that retrieval tool quality does matter. Leo Bostov shared this with me on LinkedIn. And what's interesting to me is the first thing to realize is this is GPT OSS 20B, so it's a small model. It's a model you can run on a laptop. Um, Off the bat, just with BM25, really, here's BM25 on passage similarity. Here's BM25 on document. The other thing to realize, Browse Comp Plus is a pretty challenging agentic deep research metric. It tries to confuse an agent, tries to throw all kinds of weird curveballs at an agent to and it has all these tasks that basically tell the agent to find some complicated information out there. Well, what was impressive to me is, and I do agree that obviously better retrievers and just from before how I was like layer on different tools does help the agent perform better. But the thing that's striking to me most of all is just these really simple retrievers, an agent does surprisingly well. So I'm not saying you shouldn't care about your retrieval tool quality, but I am saying that there's as much work to do in agent and harness design and the skill design and all those things that we put on that side of the equation as we do on the retrieval tool side of the equation. And really what this is doing, we look at the entire thing. What we're really doing um, is we're unbundling the big search stack that I showed before. So this is really, I think, what's interesting about agentic search is you can optionally unbundle and just let the agent drive all of the pieces. So query understanding just becomes part of the LLM. We have search tools. Those just become the retrieval arms, the retrieval sources. We have the LLM's own evaluation that's kind of a re-ranker. You can plug into these, honestly, the query formulation should have an arrow too. You can plug stuff in here, like the evaluation, to external judges or re-rankers that can help figure these things out. And what we're really doing is bringing everything into the reasoning loop and helping an agent think through how it should be using its retrieval tools to pull back relevant results. And this is why you're seeing people talk about things like, well, let me just build search with grep. Let me just put a bunch of markdown files in the file system. Maybe they're organized somewhat and build search with grep, and the agent will figure out how to find things through regular expressions. Because we have this reasoning loop and this sort of the semantic part basically becomes part of the LLM and not part of the embeddings. Yeah. So LLMs become the semantic layer and they become the eval ranking layer. And it's getting to the point where instead of the tuning, where we're actually changing things is we're not necessarily always going to be changing retrieval tools and the stuff around the agent, but the models themselves are getting faster and more focused on search. There are startups like Sid, like I said, who this is their entire thing is focusing on this agentic search task. So there's this new problem. We have this proliferation of options now. So if you do everything I just said and you throw the kitchen sink at an agent, what I've done is actually give you a different kind of problem. And it's kind of like the curse of dimensionality because an agent coming into the world, remember agents, when they start a task, they start with their encyclopedic knowledge of the world with very little context of what's it's done before. It has no what it's done before. It just starts formed with the encyclopedia of all knowledge. Well, an LLM has to play with all of these widgets and gizmos and things that we've given these filters, and maybe it should use grep for one thing or BM25 for another. So it's going to burn a lot of tokens doing that. So that's the first thing that you see when you start to play with this. And what I see is that a few years ago, when people were doing RAG startups, I think it was reasonable to say, oh, it's silly because they're just sort of like throwing some embedding somewhere and it sort of kind of works, but not really. This is now a bit of where startups are finding themselves a little bit in a corner with this stuff, and where maybe if you go too far in this extreme, you might run into trouble. But there's mitigation. Of course, we can mitigate this on the retrieval side by making it smarter and more deterministic. We all know that. But I think what's also interesting from this perspective is answering, building these harnesses in the same way we build our coding harnesses. So in Claude Code or something, when we have this challenge of, wow, we have an entire operating system full of commands, a command line tool for everything, and a huge code base, and we need to tailor it to solving a specific type of problem, we create skills. So we say, oh, if you want to figure out how an Elasticsearch cluster is structured, you go and you go to cat indices and you do all these things. And this is the step-by-step procedure you should run. So you're not wasting context doing trial and error a million things. And I think the same thing can be true of search as well. We have skills. I've just came from a client that called this a query plan, which I think is also really an interesting idea. We can have skills for solving specific problems. Like when searching for company financial data, use the filter report type earnings. You might say ignore the other filters and use the BM25 search. So this might encompass a large set of search problems that basically avoid wasting a lot of context iterating and trying these different tools that we know won't necessarily get to a good outcome. So that's the first thing. The other challenge comes when with guiding reasoning itself. And this is also something we do with coding agents. So this comes up in like Carpathia's auto research. This comes up in coding tools, where a lot of how you get these really autonomous agents, how you get really good work out of them is and really more deterministic work, is you build good guardrails around them. So LLMs will kind of throw spaghetti at a wall, and I see this with query expansion too. If I just let it go and give it a lot of search tools, it'll try different queries without necessarily rhyme or reason, or at least not clear rhyme or reason. Um, and it might do a decent job. But we can also have, and I sort of alluded to this before, we can also have a hook. I like to call it a hook because that's often what we refer to it in a coding agent that programmatically checks the results that came out of the agent. And if something is off, or it doesn't pass a smell test, or there's actually a sub-agent, maybe a cheaper sub-agent that's really good at evaluating search results, it can tell the agent to try again. And the agent can go, oh, okay, well, actually, wow, that assumption I made is not correct. Let me go and change how I'm going to use these different search tools. Um, and so you end up with these three ingredients that you trade off of when you're building agentic search. You have hooks that sort of like programmatic guardrails that steer the agent. You have skills that help the agent. So hooks are reactive, skills are proactive. Both hooks steer an agent towards the right answer by looking at what it's done and correcting it. Skills proactively guide the agent to what should be done. And then, of course, you have retrieval, which are meant to fulfill the promise. In some ways, fulfill the promise the different skills that talk about it are making. Like, if I do filter on this, will it actually filter on this? If I search this way, will the results make sense? So retrieval needs to make sure that the actual tools are understandable in terms of what the skills are telling it should do. And you have naive retrieval. These are all the people building search with grep. But what they're really doing is they're putting all their complexity into hooks and skills. So anyone building, using OpenClaw or something like that, what they're really doing, OpenClaw is almost this like operating system for being able to use skills and to accomplish any number of tasks, sometimes correctly and sometimes deleting all your email. But the emphasis in the design there will be people will talk about the skills they're using and maybe the constraints and programmatic hooks they're putting around the agent itself to prevent it from going off the rails. The other end of the spectrum, and if you're ChatGPT or your Google or your Anthropic, you live more in this world. Although recently I saw Anthropic did post something about how they do some post-processing of search results that I thought was interesting. So you have hooks and skills sort of existing, but they're much lighter in this context. But we have a strong retrieval tool that we trust more. So we trust, OpenAI can trust Google or Bing to actually give reasonable answers and do a good job to answer the question. And sometimes the right answer of where to invest may depend entirely on just your team's comfort. Like maybe you work at a search team and you are actually comfortable building a good retriever. But a lot of people might be able to start with hooks and skills and gradually build up the complexity of the retriever as they're noticing tokens wasted and these kinds of things. Yeah. Yeah. So just repeating what hooks do, sort of checking, sanity checking results, or even evaluating results. Um, Retrieval fulfills a good contract and skills guiding in specific situations. So I want to stop or conclude, and then I'll answer some questions, what you should do. I don't think where I see people messing up is they'll say, oh, we need to build RAG. That means we must build chunk and embeddings. And so they'll take 6 months and build this really complicated project of we must have this chunkable index of knowledge. I actually think that's usually a mistake because it's a very high scale problem. It's a lot of infrastructure. It's not clear you're going to need it. I think it's better to just expose some tools and get started and ship a problem sooner and see where the gaps are before going to the next level. Maybe you do need to do chunking and that kind of thing. But maybe there are other ways that already exist in your data that expose that knowledge in a different way that speaks in a not a natural language way of thinking about the data, but a more metadata first way of thinking about the data. I also think it's reasonable to, especially if you're not familiar with retrieval, but you're more comfortable with AI and agents, you can focus on the harness and the skills and get to the retrieval part later. Eventually, it's going to matter. Eventually, grep is going to not be able to search billions of documents, but you'll get there when you get there. And just starting with something you can ship sooner is the most important thing. Yeah. Um, and each of these areas has very clear next steps of what to do. So with that, I will just stop and see if folks have any questions or disagreements. I know it's sort of like this is very hot take. And if this topic interests you and you want to learn more about agentic search, there is, like I said, there's a discount code. RAG is dead, which is a joke. RAG's not really dead. And you can go to maven.com, software to cheat at search if you want to hang out with me. So yeah, I'll stop there. Any questions? Oh, there are some questions in the um, in the chat. Let me get to those. So C. Fryer asked, "What do you think about recursive language models? Call loop inside a REPL with API to a Vespa server and/or another database." So I've had a lot of luck with recursive language models. So recursive language model, the purest form of it is instead of giving a tool to a search system, you give just a tool that is a Python REPL. In some ways, it's like having a tool to bash that can call grep and exploit a file system. Except with on the Python REPL, usually the context is defined to be a variable in the REPL itself, so in the Python process itself. But the recursive part is interesting because you also add to that Python environment a function that can then itself call an LLM to do certain tasks. It works really well. The main challenge is gets back to my skills discussion before. If you want the LLM to do something smart if with that function that calls an LLM, if you want the agent to do something smart with that function, that recursing function, I find you have to be specific about what you want it to do with it. Like understand cruise, try to understand cruise with it. You have to give it kind of more careful examples. And this is generally true of agents and LLMs. It's like you kind of need to steer them a bit about what you expect when you give them something really open-ended like that. Juan Pablo, yes, asks, doesn't this drive the cost of search way up? Assume the agent has to go over and over multiple search cycles to get the results. Yeah, I don't want to de-emphasize that is a trade-off. So that is something you have to reckon with. So some people will say it doesn't. Some people will be happy about it because they get some good results quickly. They're able to ship something sooner, and then they'll come back and iterate on it. Um, Other people will say, no, I need to stop and think about my retrieval to be able to tolerate the costs of these things. And it sort of also depends on where you're starting. If you're starting in a RAG-like environment, um, that is, you may already have a few rounds of tool calling and things like this. So you really have to measure where the trade-offs are. Anna asks, I've heard that the search functionality in Claude Cowork is distinctly different from RAG. Could you please elaborate on this? My understanding, I don't know if this is the same as Claude Code, but they definitely don't have the classic chunking vector database setup. I think their search setup is, well, in code, there's this concept of a trigram index where it makes it easier to search, like basically search within strings. So they care more about that kind of thing. And I think they just use a lot of file system tools, but don't quote me on that. I don't know if anyone else has information on that, uh, please mention, please bring that up. So Shishir asked, how does one budget for latencies on repeated calls? Um, Usually, that's a great question. I don't know quite what you mean by budget latencies, but in my experience, depending on the situation, we're in a phase right now where users are comfortable with a degree of latency to get good answers back in a chat and RAG context. I think ChatGPT has trained people to expect thinking and those kinds of things. So typically, I haven't seen too much of a problem. I think it's interesting though to basically to go and look at the developments that are happening where people are looking at cheaper models are trying to train treatment models that only focus on the search part of the equation. Anna asks, what, how do you vet, how are you vetting the Hugging Face models? So I vet Hugging Face models the same way I'd vet any search solution. I would need to have some way of evaluating their quality in terms of question. So there's this concept in search called a judgment list, and I'll pull that up. Whoops. What is a judgment list? Um, that is often labeled, sometimes depending on your situation, might be derived from clickstream data. Really, there are classic evaluation metrics in question answering that basically you have a evaluation set, you know the right answer, and you're trying to see how good the retriever is at surfacing the right answer. So you see how far up in the ranking the right answer shows up. And I wouldn't, I don't think you can get away from doing that on your own data and comparing it to and just comparing different models using your own data. And honestly, like actually gave a talk entirely about this with Hamel Hussein that he just posted on LinkedIn, and I'll have to find it, but I wonder if I could find it. It's not here. But there is a talk, I think it's like how to debug rag Doug Turnbull. Let's see. Yeah, here we go. Uh, if you're interested in the evaluation topic of this, definitely check it out. Any other questions? Yeah, John, good to see you. Thank you. And definitely come to my training if this topic interests you. I think you'll get a lot out of it. I got I think a lot of people got a lot of information out of it, from things like recursive language models to agentic search harnesses to building good retrievers for agentic search. Yeah, Deb asked how LLMs like Claude agentic SDK perform trade-off between skill tool calling hooks between all the iterations for optimal retrieval results. Do traditional Python data structures? I actually don't know for trade-off between skill tool calling. Oh, I think something. So the fourth thing that's I'm not mentioning in here in this talk, just because there's so much to talk about, is in part because it applies very specifically to coding, and it applies very specifically to, I would say, a specific kind of search, like web search. But uh, a lot of it just has to do with training data, like something like Claude Code can do a lot through training data, or has a lot of training data that guides it on like on using grep or exploring a file system. So that's one reason that people are like, hey, I'll just use grep for my search, because there are so many examples, a lot of it driven from actual use your telemetry, that help it search more efficiently in a file system. So that's why like Claude Code um, doesn't necessarily need to figure out like how to like do a sophisticated search. It doesn't need guidance on that. It's like been really baked into its training data. Cool. All right. Well, that was great. I hope everyone had a good time. So definitely either come check out my class, or I'll see you next week as I chat with Joe Christian. All right. Take care, everyone.